Addition theorem. Given more than one events in a sample space, addition law implies the probability of occurrence of at least one of them. Let A and B are two events and are not disjoint, then the probability of the occurrence of A or B or A and B both, in other words probability of occurrence of at least one of them, is given by P A union B equal to P of A plus P of B minus P A intersect of B. 1. P of A union B, probability that either A or B happens. 2. P of A probability of event A. 3. P of B probability of event B. 4. P of A intersect of B, probability of A and B happening together. 5. The following Venn diagram explains addition law of probability. Example: if the probability of happening in event A is 40% and in event B is 30% and both of them is 10%, then the probability that at least one of them occur is 0.4 plus 0.3 minus 0.1 equal to 0.6, that is 60%. Corollary. 2. Corollary. 1. If the events A and B are mutually exclusive, then P of A union B equal to P of A plus P of B. Example: if the probability of happening in event A is 40% and in event B is 30% and the events are such that they can't occur together, then the probability that at least one of them occur is 0.4 plus 0.3 equal to 0.7, that is 70%. These events, which can't occur together, are called mutually exclusive or disjoint events. 3. Corollary. 2. For three non-mutually exclusive events A, B, C, we have P of A union B union C equal to P of A plus P of B plus P of C minus P of A intersect of B minus P of B intersect of C minus P of A intersect of C plus P A intersect of B intersect of C. 4. Corollary. 3. If A and B are any two events, then P of A equal to P of A intersect of B plus P of A intersect of B C. 5. Corollary. 4. If AC is complementary event of A, then P of AC equal to 1 minus P of A. 6. Corollary. 5. P of B intersect of AC equal to P of B minus P of B intersect of A. 7. Corollary. 6. If AB implies P of A less than equal to P of B. 8. Corollary. 7. P equal to P of AC intersect of BC equal to 1 minus P of A union B. Conditional probability. 9. It is the probability of happening an event that is based upon a condition. Example: Rohit has given two tests. The probability of his passing both tests is 0.6. The probability of his passing the first test is 0.8. If the probability of passing the second test depends on passing the first test, then the probability of his passing the second test given that she has passed the first test is called conditional probability. 10. The conditional probability of an event A is the probability that the event will occur given the prior information or knowledge that an event B has already occurred. We say probability of the event A given the event B has already occurred, and denoted by PA by B11. If the events A and B are such that the occurrence of A doesn't depend upon occurrence of event B, the conditional probability of event A given event B is simply the probability of event A, that is P of A12. Similarly, probability of event B given that event A has already occurred is denoted by PB by A13. Multiplication theorem. If A and B are two events of a sample space S associated with an experiment, then the probability of simultaneous occurrence of events A and B is given by PA intersect of B equal to P of A P of B by A equal to P of B P of A by B14. Independent events. Two events A and B are independent of each other, if the occurrence or non-occurrence of one does not affect the occurrence of the other. P of A by B equal to P of A, P of B by A equal to P of B. Thus PA intersect of B equal to P of A P of B. In general, if there are three independent events A, B and C associated with an experiment, then P of A intersect of B intersect of C equal to P of A P of B P of C. Illustration. 1. 1. If A, B, C are independent events such that P of A equal to 0.3, P of B equal to 0.1 and P of C equal to 0.2. Find the probability of simultaneous occurrence of all the three events. Solution. 2. A problem is statistics is given to three students A, B, and C, whose chances of solving it are 1 by 2, 3 by 4 and 1 by 4 respectively. What is the probability that the problem will be solved if all of them try independently? Solution. Point 3. Find the probability that a card drawn from a pack of cards will be a red or a picture card. Solution. Illustration 2. 4. Suppose we draw 2 cards from a shoe-ed set of 52 playing cards. What is the probability that the second card is a queen? Solution. 5. Assume that a certain school has equal number of boys and girls. 5% of boys are football players. Find the probability that randomly selected student is a boy and football player. Solution. 6. Susan took 2 tests. The probability of her passing both tests is 0.6. The probability of her passing the first test is 0.8. What is the probability of her passing the second test given that she has passed the first test? Solution. Illustrations 3. Illustrations 3a. Illustrations 3a. A problem in mathematics is given to 3 students, whose chances of solving it are 1 by 3, 1 by 4 and 1 by 5. 1. What is the probability that the problem is solved? 2. What is the probability that exactly one of them will solve? Solution. Let A, B and C be the events of solving problems by each students respectively. Illustrations 3b. Illustrations 3b. The odds in favor of A hitting a target are 3:4 and odds against B hitting a target are 1:2. If both of them shoot the target independently, what is the probability of 1. Both hit the target. 2. Only A hits the target. 3. At least one of them hits the target. 4. None hits the target. Solution. Illustrations 3c. A and B are 2 independent events such that P of A equal to 0.3 and P of B equal to 0.5. Find the probability that 1 both A and B will occur. 2 only A occurs. 3 only B will occur. 4 at least 1 will occur. 5 none will occur. Solution. Illustrations 3c. Exercise 2. Random variable. Random variables is a real-valued function defined over a sample space S of a random experiment. The values of the random variable correspond to the outcomes of the random experiment. It is a function, where domain is the sample space and range is the set of all real numbers. Mathematically it is defined as x, SR, where S is the sample space of the random experiment under consideration and R is the set of real numbers. The use of random variables is most common in probability and statistics, where they are used to quantify outcomes of random occurrences. For example, if I toss a coin, I get head and tail. I can't do any further calculations with head and tail until we quantify them, like, number 1 replaces head and number 0 replaces tail. Consider the random experiment of tossing a coin 3 times, and observing the result for each toss. Let X denotes the total number of heads obtained in the 3 tosses of the coin. Random variable. There are 2 types of random variable, discrete and continuous. Discrete. The random variable, which takes finite or countable infinite number of distinct values, is called discrete random variable. Consider an experiment where a coin is tossed 2 times. If X represents the number of times that the coin comes up heads, then X is a discrete random variable that can only have the values 0, 1, 2. Some other examples are number of students in different classes, number of members as a family in a city, etc. Random continuous. The random variable, which takes any value within a specified range or interval, and can take an infinite number of possible values, is called continuous random variable. Some examples are amount of rainfall in a city over a year, the average height of a group of 25 people, etc. Variable. Discrete. Continuous. Probability distribution. A probability distribution is a statistical function that describes all the possible values of a random variable X and its corresponding probabilities that X can take within a given range. This range will be bounded between the minimum and maximum possible values. The probability distribution of a discrete random variable is called probability mass function, and is denoted by f of x. F of x is called the probability mass function if it satisfies the following properties: f of x greater than 0 and f of x equal to 1. F of x is called a probability density function if it satisfies the following properties: f of x greater than 0, f of x dx equal to 1. And probability that a continuous random variable will assume a particular value is 0. Diagram of a probability mass function. Diagram of a probability density function. Diagram of a probability mass function. Diagram of a probability density function. Cumulative distribution function of random variable x. Suppose a bank is having a data of number of customers taking loan month-wise. By dividing the frequency by total frequency, one can find the probability distribution of customers taking loan month-wise. If one is interested to find what the total probability of customers taking loan is by half of the year, one has to add the probabilities up to that, which is called cumulative distribution function of random variable. Thus, cumulative distribution function of a random variable x is obtained by adding the probabilities of a probability distribution. The cumulative distribution function of a discrete random variable x with probability mass function f of x is defined as diagram of cumulative probability distribution. The cumulative distribution function of a continuous random variable x with probability density function f of x is defined as diagram of cumulative probability distribution. Diagram of cumulative distribution function. Properties of cumulative probability distribution. 1. 0 less than equal to f of x less than equal to 1. 2. F of minus infinity equal to f plus infinity equal to plus 1. 3. F of x is non-decreasing function. 4. F of x is a step function and continuous from right. 5. If a and b are two real numbers. Distribution function. Expectation and variance of random variable. The mean e of x of the random variable is the value that is expected to occur per repetition if an experiment is repeated a large number of times. Expectation is the average or mean of the distribution. For the discrete random variable x, expectation of 10 is defined as e of x equal to x f of x, where f of x is the probability mass function of x. If g of x is a function of 10, e of g of x equal to g of x f of x. For the continuous random variable x, expectation of x is defined as e of x equal to, where fx is the probability density function of x. If g of x is a function of x, e of g of x equal to the variance w of x of the random variable x measures scatteredness of data is defined by the formula. The variance of the discrete random variable is given by. The variance of the continuous random variable is given by. Properties of expectation and variance. Illustration. Find expectation, variance, standard deviation and CDF of x, when x has the following probability mass function. Also find e of 5x plus 10, and w for x plus 3. Solution. Solution. 1. Find expectation, variance, standard deviation and CDF of x, when x has the following probability density function. Solution. Exercise 3. Binomial and Poisson distribution.